I want to present a different paper about passive optimization in a low frequency square periodic metamaterial and diamond shaped hole, which we try to prepare active metamaterial or 4D metamaterial in our next papers, but it's an introduction for our next design. And if I want to talk about a little bit about metamaterials, it's good to say we all know about metamaterials and their different usage and their different application in various structure and in various applications. But here I bring sound filters or vibration filters that we want to focus on that because we want to prepare structure that can filter waves and sounds. And because of that, we can prepare band gaps and sound attenuation waves in a specific vibration or a specific frequency range. And application for this design can be ear noise filters or ear adaptive noise filters. And as you can see in raw materials or in different specific materials, sound can easily propagate. And in our design or passive design, we try to filter this sound. In order to make or prepare these structures, in our next papers and next research, we want to try to make some adaptive structures which can prepare in two different ways. First, with printing magnetic structures that we want to try, and we want to work on them with MREs. And also it's possible to prepare but casting with magnetic structures with casting and laser print, laser cut or magnetization in these structures. Sorry. Okay, if I want to talk a little bit about periodic square structure, in periodic square structures, we don't have any band gap, as you can see here in the range of low frequency. All the waves can propagate. And also in other structures that I prepared here from paper, they try to prepare transmittance in different frequency and to see what will happen by changing magnetic field and changing materials and changing material properties. As you can see, they try to change the position of band gap. But here we want to work with the periodic structure, different theory to change this band gap area or to prepare band gap area to work on adaptive structure. And if I want to talk about material method in this structure, we already have unit cell for square unit cell that we can bring that in a periodic structure in periodic arrays. And by changing the whole diamond hole inside the that unit cell by changing that in a passive way, not in an active way. We can change its shape, and we have some passive design parameters here that they are easily changeable. And also we try to put material properties for our structure for as MREs that we have another paper in publication that they are used actively. And to have simulation on and to know the wave propagation analysis, we have to use block theorem and to simulate our structure with this governing equation that's a well-known governing equation that depends on different different wave numbers around the specific Brillouin zone for square structure. And as you can see in our simulation, in the angle of alpha that I showed in the unit cell, when it's in alpha is 0, we don't have any specific band gap between 0 and 15 kilohertz. And by changing this degree, we can see some specific range of band gap can be appear here, and we can see the mode shape of this specific structure in different frequencies. And also by changing that to higher ranges, we can see the different areas showed up for 3 different area of band gap. It is going to be more specific area to filter noises or filter sound. And by changing to the 45 degree, we can see it's in the maximum area for this structure, because I will show you in next slide. And it can filter a specific area for between around 7 kilohertz to 10 kilohertz. That by using active materials like MREs in these structures, it is easily available to change these propagation waves places, and that can be active metamaterials. I also bring that the data from that wave propagation analysis as a between the relation between band gaps and angle, and you can see it's gradually going up, and with the same relative density or with the same material, it's possible to bring a high range of band gap. And also it's possible to change the shape of hole inside that, and this phenomena happened because of different mass distribution around the unit cell. And if I want to conclude the whole thing here in this model, I want to say different mass distribution around the unit cell can present new stop band areas, and around that it can prepare new filters. And also changing this whole direction can bring new band gap areas. not wider, or we saw that it can bring different areas. And this passive band gap and in sound frequency range can be actively 4D printed and can be actively used with applying magnetic field, and also can be adaptive vibration filter. Thank you for conversation.